How can CISOs and AppSec leaders, how can we really secure the next decade of software development? It seems like right when we got a grasp over things, artificial intelligence comes out, and not only does it come out, but it starts to give us these amazing things, prompt responses. And then all of a sudden, it's starting to carry out our coding for us in an agentic way. It's not if this is going to change software development, it's when, and the time is now. Run the intro.
Who says tech can't be human?
What's going on, Hacker Valley fam? Welcome back to the show. Backed by popular demand. One of our most popular episodes this year was actually a live stream that started all here on LinkedIn. It was a live stream that we did with Varun Badhwar, co-founder and CEO of Endor Labs. It was so good that we had to do it again. And today we're going to be talking about AI-assisted development and how it's redefining how fast organizations and teams are moving and how fast we need to move to secure. So my special guests for this episode are Varun Badhwar, co-founder and CEO of Endor Labs, and Henrik Plate, who is the principal security researcher at Endor Labs. Welcome to the show.
Thanks for having us. I'm happy that the first one went well enough that you have me back here. And I've got more horsepower with me this time with Henrik accompanying me.
Yes, excited to be here. Thanks for having me.
Glad to have you both. I was going to start just by jumping straight into artificial intelligence and software development life cycles. But what's the inspiration behind the background, and does it tie into Endor Labs?
Totally. Look, we love the play on Star Wars themes at Endor. A lot of people ask me, how did this name come to life? We were just watching Star Wars on TV, and my brother-in-law just kind of jokingly said, well, why don't we play around some of the Star Wars themes? And we tried a few things, and lo and behold, Endor and Endor Labs was available. And we said, we're going to start with it. And at some point anyway, we'll probably change and rebrand the company. Cybersecurity and technology is a very serious industry, and trying to bring some lightheartedness and humor into it always helps.
I thought it would be great to bring up the State of Dependency Management report, the report that actually kind of like inspired the outline for this conversation that we're going to have today. And I like to always start with, why is this needed right now? Henrik, I know that you had a major hand in this. You're actually one of the co-authors of this report. Why write this report, especially so close to 2026? There's 2025 right at the top. Why write the report, and why is the industry needed right now?
Yeah, well, the industry needs it right now because AI and AI code assistants are transforming the way we develop software. And so we wanted to have a look at the security implications and security risks coming with this revolution. And in particular, and which is a broad field, right? So we picked a few smaller topics, a subset of the risks, and did a couple of experiments that I'm going to talk about later on. And in particular, we wanted to, understand how enterprises can use those, technologies in their environments, benefiting and reaping kind of, the advantages and reducing the risks.
One of the things that I've observed and also have experienced this year is MCP servers. MCP servers have been going wild. And I say they've been going wild because anyone can create them. This is like if someone were to make open source technology, previously there was maybe a few people that would go into building an open source library. But now with MCPs, it's like you can make something a little bit more composable, a little bit smaller, and it's generally developed by one person to few people. So, what has been you all's analysis or observations on MCPs, software development lifecycle, and, state of security for MCP specifically?
We're talking a lot about AI coding, and obviously it is of incredible importance and value in the right hands. But I want to first and foremost distinguish between kind of this whole fad about vibe coding that we're hearing a lot about versus kind of actual acceleration of software engineering, which is giving these tools in the hands of trained software professionals to be even more productive. Even within Endor Labs, all of our engineers use some of these tools. Cursor's pretty popular amongst our employee base. And I commonly walk in the halls, hear from engineers, hey, I'm 50%, 40% more productive now with these tools. But again, I caution to say, when given to people with the right hands who can oversee it, put the right guardrails, and really work with it while it's paying attention, is where this technology is most powerful today. The genesis, we have to remember, all of these AI coding agents have universally been trained on code on the internet. So they have learned the good practices, but they've also learned all the poor practices, the quality issues, the security issues. In fact, there was, we see a lot of benchmarking on AI coding agents and, how good they're at writing functional code, but there's not a lot of studies on kind of the security aspects of it. Until recently, there's a paper out there that was at Carnegie Mellon and Columbia and a few other universities collaborating on a paper called Is Vibe Coding Safe? Benchmarking vulnerability of agent-generated code in real-world tasks. And essentially what it found is, while these agents can produce like 70 to 80% functionally correct code, almost the same percentage of code is insecure. So only 10% of code generated by AI coding agents is functional and secure.
First of all, I mean, I'm not sure to what extent the audience is familiar with those, right? They are kind of the hand and feet of large language models in order to act on behalf, right, of those models, to generate code, to test code, to debug these days. And so what we wanted to understand is how many of those MCP servers are there, and what are their security or some of their security properties. So you remember the model, the MCP protocol has been created by Anthropic in November 2024. And the first thing we found is, once more, that the open source community showed being incredibly innovative and fast in embracing this technology. So since in summer, when we ran the experiments and collected the data, there were more than 10,000 of MCP servers being available in open source repositories. In a single week of March alone, there have been 1,000 new repositories being created. Incredible. So it's great.
Just for MCPs, right?
Just for MCP. We're just talking about MCP servers. So that adoption is great. So in terms of the security properties, what we wanted to understand is, how secure is it for developers to just pick a random MCP server and integrate it into his or her development lifecycle. So we looked at, are there any license information? Is there any license information available? Are there known vulnerabilities in the dependencies of the MCP servers, which is kind of, one of the STA-like features. Or we looked at the use of so-called sensitive APIs, which are APIs that perform security critical operations, such as reading environment and variables, or executing dynamically code. So these were kind of the properties we looked at. The takeaway basically is that while the open source community was great producing many of them, which is a good thing, consumers need to be careful which ones to pick and integrate them in their enterprise development lifecycle, because they have different qualities. So many don't have license information. A lot of them use the security sensitive APIs, which requires the developers to put security controls into place in order to not have all kind of injection attacks. Depending on the programming language the MCP server is developed in, they have up to 5 known vulnerable dependencies. So just some example numbers from the experiments we run on those.
I wanted to ask you both a very direct question. Can you trust the MCPs? Is it 50% yes, 51% yes, or 49% yes? Can we trust the MCPs that are on GitHub in their current state without running our own security scans? Like, I code a lot. Can I download something, and should I assume that I'm vulnerable now, or should I assume that there are some security components built in?
Look, just like you wouldn't want a stranger walking into your house, you wouldn't want strange code, unknown code, whether it's traditional software and dependencies or MCP or models from Hugging Face coming in without proper verification. There's obviously a lot of good work being done by the community. I don't want to take that away. But also, attackers are finding out that there's been this implicit trust that we have all had in the open source community. We've been accustomed to just picking stuff off these communities without verification. And that is now getting exploited every single week, right? Another big piece of the work that Henrik and his team do is we have malicious package detection, malicious library detection. They're scanning hundreds of thousands of packages in the libraries on a weekly, monthly basis. And every time there's a new project out there, we're scanning it, looking at 150 plus properties. And every single week, right, we find something or the other that's malicious in nature. So everybody should have appropriate verification capabilities, not only at the onset of a project, but also as you continue to get updates, because a lot of the attacks we have seen is it might be a legitimate library, but it gets subsequently compromised and you get an update that has issues. In fact, maybe Henrik can share one of the craziest ones we've seen where, Henrik, I'll let you talk about the one where it was using your own AI agents to scour stuff on your laptop.
I think to your question, this is third-party code running on your system, right? And you need to vet it in the same way that you vet any other piece of code that you allow to your computer. In terms of malicious open source packages, supply chain attacks that we have seen recently, I believe it's like 2 months ago, and there are thousands and thousands being published. This one was noteworthy because it was the first of its kind that took advantage of agents being installed on the developer systems. Those developers of agents need to be very careful to, protect the abuse of those agents, those very powerful agents. In this particular case, though, I'm not sure how many times this was really successful, right? We found, though, that was quite interesting. We found one conversation where the malicious package indeed talked to Claude Code, but Claude Code denied colluding with the malicious package, saying basically, no, I can't do this, cannot trade. So in this case, the guardrails worked, but we don't really know. We know they do not always work. Let's put it that way.
For sure. Wow, that is really cool from like a hacker standpoint to inject just a prompt into someone's system. Like maybe you've already compromised them and you know that they have agents running, and you could just pull down and interact with other applications that you normally wouldn't have access to as well. And I could see like even especially looking at all the people that use Claude Code, there's a hooking system built into Claude Code. I feel like there's a lot of opportunity that we have when it comes to the agents deploying their own guardrails, but our guardrails on top of them. Is that something that you all are seeing? Are you seeing that, one of the strategies is implementing guardrails through prompts, or do you need more security controls? How does Endor, tackle this beast of AI software development lifecycle?
As I said earlier, even if you have 60-70% of the code functionally correct, only about 80+% of it is insecure. The fundamental problem is, one, the agents are trained on all of the code on open source. So they're seeing the good practices, but they're also seeing kind of the poor practices. And they don't know how to distinguish between that. So a lot of the code they're producing has those same problems that exist. The second thing is the delay between when these models have last got training data and refreshed, and the fact that every day we find new vulnerabilities in software. And so we find things like it's continuously giving suggestions of packages to use and dependencies to use from the internet that are known vulnerable, but you don't have that understanding. So what does kind of a good control framework look like to kind of still use these tools, which we think are incredibly useful, but have the right guardrails in place? So first and foremost, we think even doing security at a PR level is too late. You have to be in the developer workflow in the IDE, and not only traditionally following the old-fashioned way of find security problems, log a ticket, let a human fix it, But really, how you build a security co-pilot that has all of that security knowledge and awareness to be able to hold the coding assistant accountable and essentially help it to produce more secure software by default. So how do you bring the fact that the 80% of the code is insecure down to near zero? And we have built architectures that allow you to do that at Endor Labs, where essentially we will plug into Cursor, into Copilot, into Augment, into whatever your favorite tool of choice is. And the best capability we have there is informing the agent where they're making coding errors from a security perspective, and more importantly, giving them the guidance on how to fix it. Because what we find is if you don't give it very directed information on how to fix, it churns, and it kind of burns a bunch of tokens and doesn't end up doing the right thing anyway, or it causes more problems.
I have to jump in for a second and share some details about our sponsor for this episode, Endor Labs. At Endor Labs, they know that fixing is even more important than finding. Endor Labs uses program analysis to create a simulation of your entire application at the time of build. This means you can see all of your remediation options in one screen, and you know what will break if you do make that upgrade. Sometimes upgrading is too hard or too dangerous. In that case, you can use Endor Labs backported security patches that has been tested and maintained just for you. Finally, you can refactor code at your own schedule. You can learn more by visiting endorlabs.com and let them know that Hacker Valley sent you. Thank you, Endor Labs, for sponsoring this episode. I'm interested to know, how would someone go about scanning or discovering these security flaws if they vibe coded the app? The AI agent could have written thousands of lines of code. I think, especially when we look at speed of organizations, it's not really feasible to go back and audit it by hand and then have someone else audit it by hand. Like, does trying to automate the review process, is that what also burns us? Or is there a way that we could intelligently go about asking an AI agent to do a security review?
We think while AI and the foundational models are getting better at coding, we think there's an opportunity to leverage them with the right context and the right data to actually allow these models to be trained to be security experts as well. Now, you can't just take, you could take a generic model and ask it to do a security review. It'll probably do a reasonable job, but it'll be high false positives, high false negatives, which is typically the problem you try to solve in security. And I always caution people, it's great. You could build AI demos in 30 minutes to an hour these days, but trying to productionize this, especially with security where determinism does become important to some degree. Reliability is critical, right? You want to reduce false positives and false negatives. And so, we have certainly here at Endor invested a lot of time and capital, and we have incredibly smart people that are working on actually training and specifically building capabilities where AI agents can be used to do security code reviews. But essentially, we still believe the world generally needs humans in the loop. And so what it does is it will significantly reduce the burden of work for the human, such that even with 10 times more code, you can do the work with the same amount of humans. That's kind of our goal and objective today.
What I think is important to, again, I've mentioned this earlier on, to be aware that different types of vulnerabilities are, easier or more difficult to generate, but also to find during the reviews. And the example I typically take is that of SQL injection. It has been haunting us in the industry for years and years, but still, it's a relatively simple, in quotes, vulnerability, and in particular, how to secure the SQL injections is relatively straightforward with these prepared statements.
There's been a term that we've all been kind of like drowned with. It's shadow IT. And, there's a few years ago, SaaS companies started to say shadow SaaS, but now there's like this shadow tech where it's not even IT or stuff that you're buying, but it's like shadow security debt. So what are you all's outlook on, that being introduced to organizations, and how do we, manage the fact that there are people doing a lot of AI development when it comes to like software development?
Yeah, I call this a shadow engineering problem, right? It's not an IT, but it is all the things that are used in your SDLC to create software. And, some examples of that is Most customers we talk to don't even know what models their teams are pulling down from Hugging Face. I mean, it's incredible to see. By the way, Ron, like Hugging Face has 2 million plus models now and growing rapidly. Like that's GitHub for models. How do I even figure out what models are my teams using? Are they reliable? Are they trustworthy? What are the agents my teams are using for coding? What are the MCP servers that are integrated on the client? Like when we thought about securing our software, I can't even say it traditionally, even like 2 years ago, we thought about the CI/CD pipeline being the place that you wanted visibility and instrumentation into. But a lot of that is now shifting into the developer workstation and will soon be agent containers or whatever they end up being, but autonomous agents that produce your software. The other thing we think is, again, trying to figure out how do you instrument the AI coding agents in the future to know what are those coding agents doing themselves, right? Like there's interesting architectures now. Cursor and Anthropic both have something called hooks, which essentially allow you to get observability into the agents and the agents' interaction with other agents and MCP servers. And I think it will become an important architecture to tap into and get more visibility into as well.
In my eyes, hooks are the most important thing that a software developer or someone that's even just trusting an agent should be leaning on right now. Hooks can save you. They could also ruin, your processes, kind of like GitHub hooks. It feels like every time that I've committed on a repository that has GitHub hooks, it's like I can't ever actually get anything committed, but it might be, for the best. There's a lot that I would need to learn before I just jump right into being part of a software development lifecycle. And I look at, AI agents the same. Before we give them carte blanche access to everything, if we had a great hooking system, I think it would make companies, people feel a lot better with allowing them to take on action after action after action without so much human intervention.
Yep.
Yeah, totally. But look, we're talking a lot about AI as a scary thing. I want to kind of come back to the meta point being we have to embrace it. I don't want people to take away from here an excuse to say, I heard these two crazy guys on a podcast and get about how scary it is, so we shouldn't do it. I don't think that mindset will work. You have to adopt coding agents. They have a net advantage to productivity in your teams. But as we think about productivity drivers in an SDLC, in an engineering organization, also remember, security has been one of the biggest taxes that you apply to development organizations. And, one of my favorite quotes from Jen Easterly, the former director of CISA, is that cybersecurity as an entire industry is a software quality problem. If you think about it for a moment, why do we have firewalls? Why do we have endpoint protection? Why do we need cloud runtime security and other sensors? Because generally, the software we ship is full of compromises, security weaknesses that eventually people will exploit. And you want to be in the path of at least being able to detect and respond to when those incidents happen. And the reason for that is the cost of shipping secure software is generally very high. So most companies shipping software will take the shorter cut of shipping with velocity, compromising on security because the cost is too high to do both. And we fundamentally believe that AI coding agents also present yet another opportunity for us to just bring that cost of remediation down. Because as I said, if you give these agents the right context in the right place, they can actually address a lot of the security issues for them. I had a customer who was trying our MCP server, and it was an engineering organization. One of the most exciting things they came back to me and said is, whoa, like 90% of the things that you guys were flagging, giving the guidance to the agents to fix, it was just fixing for me. So no longer do I have to go sit on this backlog for 6 months, a year, 18 months. But if I surface the right context at the right time to a smart enough agent, it can actually help you fix vulnerabilities much faster as well. And so I think I want to focus also on the upside case, not the bear case only here as well.
A mental picture that I like a lot in this context is this shift left philosophy, right? We have been talking about this for so long, and in my mind, you cannot shift the security controls any further left if you integrate it at the time the code is conceived. And while it is conceived, you check for vulnerabilities, for vulnerable dependencies, and so forth. So indeed, it's an opportunity.
So it was either trust the AI agent or get a Neuralink so it's as far left as possible. Nice. I gotta ask, because I totally agree with you that this is a lot of opportunity that's been presented. It's been, a lot of opportunity even for myself. And I'm not necessarily a practicing security architect anymore, but I'm able to still, have the time to build prototypes for myself and also show them off. What was the first time that you all thought, wow, this AI technology is actually going to work? What was the experience that you had, and when was it?
I'm more of the pestering everybody in engineering to say like, hey, like, did you figure it out? Did something work? Did something work? And you're right, Ron? Like a year ago, we were kind of more skeptical about like, look, how fast is it going to get good enough? Because as a software company selling a cybersecurity product, we can't make mistakes, right? Like the stakes are too high. And so for me, it was always that question of when is it going to be good enough? I will say the first key use case where we have shipped a kind of completely LLM native capability is that use case I was telling you about, which is the having LLMs do triage and false positive detection of scam security software, essentially SAST, right? For those of you that use SAST tools, you know how incredibly noisy SAST tools are. And even the best tools in the market give you at least 50% false positives. And so that we wanted to take the entire process that a security engineer goes through once they get an alert to go figure out, is this real or not? Do I go bother my developers or not? And can we automate that kind of whole triage and investigation process? And when I saw that work end to end, it was like my eyes lit up, and now we have an entirely native end-to-end AI native SAST engine that will not only do triaging, but detection, identification of logic issues, as well as remediation. So now we're pushing full cylinders, but that was my first product conviction that I had to say, we're going to go push all the chips all in. But yeah, that's what it was for me. But Henrik will, I'm sure, have another interesting story.
Well, personally, I must say it became shortly after the release of ChatGPT, it became pretty useful, really fast. But at the beginning, I would say it was mostly a better search engine to, spare me some time searching for certain technical solutions. What was really eye-opening, the one is, as part of this experiment I was doing for the dependency management report, was the observation of the conversation logs, the interaction between the model and the tools, and how the model would invoke the tools in order to learn, what are vulnerable dependencies. Okay, that version maybe I should not use. I bumped to this other version and it was doing another tool call. So this constant refinement of the agent and tool interaction leading to more secure code. That is very personal in the last, I would say, 6 months or so.
Writing reports like the state of dependency management report, you need to have a little bit of a magical crystal ball because it takes a little bit of time to write the report and you got to do the research. So I'm sure you're going to drop more reports in 2026. If you had to get your magical crystal ball out and kind of like make a prediction on what is the state of software development and AI going to be in 2026, what will your prediction be? Let's start with you, Henrik.
I think right now we still have the human a lot in the loop. I think we will need not wait for so long in order to have agents address solutions much more independently. Just starting off of Jira tickets or GitHub issues or so, trying to solve them autonomously, and then only presenting something at the very end to a human, reviewing it or so. So kind of the human presenting a problem and describing a problem or prompting something, that will, I guess, go away, and the agents will discover and solve issues more autonomously. But then, the crystal ball predictions are always difficult, obviously.
Sometimes there's a little like cloud or fog in there, right?
No.
What about you, Varun?
Yeah, look, I think Henrik's spot on. I think you're going to be able to, as engineers, take longer lunches, go away, and come back. By the time you come back, you'll have things built out for you. I think the more important thing, though, will be how do you solve the paved roads problem? I was reading a good paper which says the organizations that have had mature engineering practices, really strong test harnesses, quality processes that are highly automated, security processes that are highly automated, will reap the rewards of this really early. I think organizations that have immature engineering processes will struggle because, you know, you're going to be running hard and fast, but you're going to be kind of just looking around and not making forward progress, because a lot of this is as good as kind of the paved roads you create for these AI agents to be successful and not cause catastrophic failures around you. But I also believe we will see more incidents, again, whether security, quality, reliability, downtime, but we will start seeing more incidents because as people let these things loose, they're not perfect. And, you know, they will come back to haunt us, but we're going to learn and get better with it, right? It's like cloud. That we made mistakes, we learned, we automated, we iterated. It's just happening a lot faster. So I think that's what I expect to see. I also expect that the naysayers are going to be kind of pushed to the side. And, you know, this is happening, unfortunately, whether you like it or not. And, you know, we all have to brace for impact and hopefully have a very successful outcome with AI SDLC.
It's always very scary when something or someone starts to you know, kind of get into your own lane. You know, I'm sure like it's a very confusing time for developers. I'm sure last year was a very confusing time for executive assistants because everybody was using a lot of tools for summarization. But at the end of the day, I think that all of this technology, it's all about how you use it. Everything has a use case. If we know what our use cases are, then you're going to be able to plug people in where they need to be plugged in, and then also plug the technology in where the technology is going to help accelerate you and lift you up.
Yeah, I think you're spot on, right? I think we can't be fearful and as a result resist this technology, mostly because of uncertainty. I think a lot of companies are still figuring out what is the impact of AI. You might have seen some McKinsey reports that say 95% of the AI kind of projects are not leading to successful outcomes. I think people are still figuring out how to operationalize AI. I think it's one thing to push a button to production. Operationalization to me is a lot more than pushing it to production. It's how you get the adoption and usage and the flywheel going. And I think the other thing is the piece that I believe AI doesn't have, right, is it's good at memorization. It's good at summarization. It doesn't have intuition. And so I think the question will become like the human capability that will become the most dominant capability will be intuition, because you're going to ultimately have to have that intuitive capability to then drive whatever projects you drive with intent with AI.
I wanted to also give you a second to share a little bit more about Endor. You know, we talked a lot about state of dependency management. We talked about MCPs, talked about AI and SDLC, but you know, all of this is around some of your core competencies and the things that you do better than anybody in the world. So what exactly is Endor Labs and what do you all help companies with most?
Great question, and thank you for asking. Look, we help the most prolific companies in the world that build and ship software, whether it's OpenAI, Cursor, Snowflake, Peloton, City, and others, essentially build a very secure software development life cycles. See, we always think of it as a large tax, and it's costly, and an average company has tens of thousands of alerts being fired by their current code scanning tools. We eliminate all of that noise. We have kind of re-architected from the ground up an AI native platform that has the context of your code, that intersects that context with the right data that we have about all of this underpinnings of software. And we basically give our customers three main things. One, you can significantly reduce, typically by 90 to 92%, the volume of alerts being fired off with your code scanning tool. The second thing is we accelerate remediation. So we have particular context that allows developers to actually upgrade their software to be more secure and compliant much faster. And the third thing we do is really help organizations embrace AI native software development, coding agents, and other things by integrating security at the right places through our MCP integrations, where the output of the coding agent is just more secure software. It's transparent to the human, really working with the agents to make them better.
Amazing. Well, I'm wishing you all the best. I'm a big fan. If you haven't done so already, you got to check out Endor Labs. You got to stay connected with Varun and both Henrik. Be sure to connect with them both on LinkedIn and be sure to follow their company page on LinkedIn and visit endorlabs.com. Varun, Henrik, I wanted to thank you again for taking some time out of your busy day to jump on the mics with us and also the audience as well. And with that, we will see everyone next time.